This is part 2 of the Super Collider synthesis tutorials. So last time we just looked at the Super Collider basics and how to set up a basic synth-def synth kind of relationship. And today we'll actually get into some of the synthesis procedures. All right, so if we look at our synth-def, we basically before had a synth, we have variable synth, and then we created a sine oscillator and we assigned a frequency coming out. Okay, which is a good way to start. You start with a sort of basic UGen, some kind of sound generation, and then you send it out. Good enough. Okay, so we'll try a couple different techniques here. First thing maybe we'll try is to just change the waveform there. And a good thing to do is to go to, if I go to the help file, which would be Command D, and if I look at go to browse, or I can search for tour of UGens. If you just put the word tour, often comes up. If I get this help file out, this will often, show me a lot of different techniques as well as UGens to use. Okay, so if I want to use, for example, the parabolic approximation of sine or the cubic approximation of sine, if I want to use like a pulse wave or square wave, something like that. And this code is runnable from within the help file as well. Okay, so easy enough. We can just change that UGen here to something else, say pulse. Okay, but of course, it could be that it has different arguments. So often a good way is just to stick a comma there into it. There you go. So we have frequency, we have width of the pulse width, multiplier, adder. Okay, so we'll just keep the frequency the same, except now it's a pulse synth. And let's just see how that sounds if we send that as a synth-def, make sure my server's booted, and then just send an instance of it. And there you go, we have a pulse wave now. Okay. So let's look at some and so that, of course, the frequency here is controlled by the arguments. So let's look at ways of combining different waveforms, maybe to create a sort of a mix of sounds or create different timbres. Okay, so you can do something like have a synth 1 and synth 2 and create another waveform we call S2, something like that. And then if I'm going to have synth be my pulse wave, we can have S2 be, say, maybe a saw wave. So I believe, okay. And then we can have another freak. And maybe in this case, we'll call it saw freak, something like that. Okay. And of course, we have to make that argument now then. We call it. And let's make that 110. Okay, something like that. Now we have two synths, but see here the way the workflow is going, the synth here, the pulse wave is coming out. Okay, so let's use the mix. UGen. Okay, and what I'm going to do here, I'm just going to eat this synth, so I don't have to keep replacing arguments. I'm going to eat this argument. So at this point in the code, it's equal to this pulse wave. At this point here, though, I'm going to use it itself and make it something else. Equals, and I'm going to use the mix UGen. Okay, and basically mixes. It's just a little mixer. Mixes your little your unit generators, your signals. And what it does take, though, as an argument is an array. Okay, it's looking for an array of various things. So basically, you have your scope declare the parentheses, but within that, you have to have an array of signals. So what are my signals? Well, synth. So you notice how I eat itself. So synth right here is a pulse wave, but at this point, it becomes a mixed signal of the pulse wave and something else, and S2, the saw wave. Okay. So there you go. So let's try that and see how that mixture sounds. Okay, that's interesting. And of course, if you want to change the freak, so we're going to change that freak to 250. We could also change the saw freak and make that say 2,000, 1,000 maybe. it's very loud. Okay, so, and you see already, just with a few additions here, you can see how now we're getting to the point where we have something that we can make something out of. That's actually can be something interesting. And you can mix as many of these as you want, hoping your computer can handle it, and keep going. And you can modulate frequency and modulate different things within it, and we'll get to that later. All right. So, but basically the idea is that this sort of this recursive technique, the self-eating technique, you can keep redefining synth as something else, and since the code is going to go in order, it'll just take itself and put it into something else, and this will be what you put out. Okay. Now, another thing we can look at doing here is having a different sort of mix. So to make it a real mixer here, we can have sort of an amplitude for each one. We can say P-amp, for example, and we can say multiply. So amplitude is just, a multiplication. So if you multiply by something by 0.5, it's going to be half its volume. Okay, and then we'll just call S-amp, something like that. Okay, and of course we have to define these arguments up here. So if P-amp equals, say, 0.5, and then S-amp equals, say, 0.2. Okay, so let's see how that sounds. Okay, and then if you want to change things later on here, you just copy this line. And we'll say, let's make the pulse wave much quieter. P and P. And we'll make that. So you have to be careful, of course, with that amplitude. It should be always under 1, or it should all, in a mix, add up to less than 1, or 1 and less. And so we'll make that 0.1, for example. And this will change the soft frequency. We don't want that right now. So now you have a true sort of mixer. Independent amplitude control, independent frequency control, the two waveforms. Kill that. All right. Now, what else is left? So we have a nice sort of way of making this continuous thing. We have a nice way of controlling the various amplitudes of each of the input oscillators, and that's already a lot. I can create some really interesting work probably just using this alone. But the next step might be to then think about using an envelope, changing sort of, instead of this continuous sound going on all the time, maybe we would cut it up a little bit or create little enveloped versions of it. Okay, so in order to do that in SuperCollider, I'm going to make a variable and I call it env. All right, and in order to do that, we use a thing called envelope generator, or envgen. So env is my variable. I'm going to make that equal to an envgen and .ar. Okay, and again declare a little scope. So the envelope generator basically gets you define an envelope shape for it, and then you have a gate which initiates the envelope, starts the envelope, all right, and then ends the envelope. So the gate argument 1 will start the envelope and 0 will end it. So you have different kind of types of envelopes. For example, you have sort of a sustained release model, which is not unlike what might happen if you hit a key on a MIDI keyboard, or if you want to just go full-on acoustic. If you think about the piano, when you strike the note, there's onset, and when release the note, it dampens, or there's offset. Okay, and that's what that gate does. 1 will start the note, and 0 will release. And that's with the sustained models of envelopes. So there's different kind of models you can use, and you'll see that. There's another model which is basically you just attack it and it releases itself. Okay, so you just give it a 1, you give it a gate, a go, and then it goes, and then it just stops on its own. All right, so let's look at both of those real quickly. So if I want to add an envelope to it, I use the env object, and this is basically just some code on the server that lets me define various types of envelopes that are preset for me. If I go .linen, and of course if you want to explore this more, just go to the envelope help file and it will explain lots of different possibilities. But I'm going to use sort of a linear envelope. And if I give that its scope there and see what arguments it's looking for an attack time, a sustain time, a release time, a level, and a curve, which are fairly typical. If you know anything about envelopes, are fairly typical things we're looking for. All right, so it looks pretty good. I'm just going to maybe use these default arguments right now: an attack, and a sustain, and a release of 1. Okay, so I'll just use the defaults there. So this will be a pretty quick attack, pretty percussive. It'll sustain for 1 second, and it'll release over 1 second. All right, so it's kind of a long gesture, and then the overall level, we'll just keep it at its basic level. Okay, and then I have to set a gate argument, so I'll just call it gate. Okay, and remember, if it's 1, it's going to set the envelope going, and if it's 0, it's going to stop it. But in this case, it's 1 trigger envelope, so I shoot it, and it sends the envelope, and then it ends it itself. All right, so I do have to make an argument here called gate, and let's just make it equal to 0 initially. And then to use my envelope now that I have this definition under this env variable, to use it, I'm going to just have to multiply, very simply, just like I did here with the amplitudes. I'm going to have to multiply that by the env. So one way of looking at an envelope is just an amplitude modulation. It's modulating the amplitude of my synth. So I'm multiplying it by this that's something that's going, for all intents and purposes, somewhere between 0 and 1, and then going back to 0 again, okay, at a different speed, right? Okay, so if I go ahead and send that to go, synth-def, you'll notice if I start it, no sound happens because my gate is 0, so it's not actually engaging the envelope. But if I set now, using this, my gate to 1, it'll trigger that envelope, and then it'll end. So it's attacked pretty quickly, we remember, and then sustained for a second and released over a second. Okay, with this sort of linear curve. Okay, so that's the sort of one shot or 1 trigger type of envelope, not the sustained shape. So in SuperCollider's case, there's a workaround for this, but generally you have to reset the gate to 0, and then you have to set it to 1 again. And there's other ways of dealing with that, but I'll get to that later. Okay, so that's still going. And remember also that the envelope technically is still going. I mean, the synth, I'm sorry, is still going. So it's still there on the server. All right. So you do need to free it if you want it to go away. Or, of course, command period will work. All right. And then this is just to bring this up now, and I'll go over it again. But this is this done action business too. So you can have it kill itself within the synth def itself. So you don't have to actually give it a 0. But then that means it's gone. Okay. So if I go done action, and I equal to 2, that means after the envelope is all done going, it's going to kill itself. It's going to kill the whole synth. Okay, so I send that, and then I go like that, and I go gate 1. It should be gone. So if I reset the gate again, it's going to say go to error, failure server not found, right? Because I have to start another instance of the synth because it's gone off my server. But then if I send it to 1 again, it says server not found. It's not found. Okay? So that's that done action. But in this case, we'll just keep it at the default 0, which means it does nothing. All right. Now that's the linear type of envelope. That's just the 1 trigger envelope. You can also have a sustain shape envelope. And that's, for example, ASR. And that follows a similar pattern. Okay? Except in this case, there's a sustain level and a release time. So it doesn't sustain for a fixed amount of time. It sustains at a certain level. And then once you give it an off message, it releases. So we'll just use the defaults there for now. And we'll send that. And if you send, nothing happens. But if I send the gate, it keeps going, going. Just like if I'm holding the key of the keyboard. It'll sustain until I release the key, and then it'll release. Okay, so this is the sustain shape. Now, if you go into the envelope help file, you'll see all the different times, and it does detail which ones are standard shape envelopes, which are these ones like triangle, sign. So again, it's this dot business that refers to these. So if I do dot triangle, I'm going to give these arguments. If I do dot sign or dot perk, or dot pairs, these are all kind of interesting approaches. And that's just the linear or the single shot envelope. Perk is something I use often as well. It'll send the envelope and end on its own. Then there's a sustained envelope creation, and these are things like ASDR, which is or most sort of typical envelope you see in modular synths and such. And then variations DA, DSR, ASR, cutoff, circle, etc., etc. Okay, so that's worth checking out. So in this case, we'll have, sure, why not? Well, won't we have a synth that we just send a normal shape, and we'll just call that linen. Okay, and now we can actually, instead of just using the default arguments, we can just make those arguments so that it becomes now quite settable. So if we, and again, I'm going to be very explicit. So if we do attack tie, oops. Okay, and then we set that to ATK. And if we do something like sustain tie, sorry. Okay. And we'll do SUS and then release REL. Okay. And if you want to set the curve, we'll just leave the level at the default 1. And we'll CCRV. Now we have to, of course, create arguments for each of these. So we'll have an attack, and we'll have a default, so maybe a percussive attack. Okay. And then a sustain. And maybe have that be, relatively short. And a release, a default release of, again, quite short. Okay, and then this curve. Okay, I think we just have to be a little careful with negative numbers. I think you do have to have space there. Okay, so if we do that, we send that, now we have a sustained shape. That's like that. Okay. And of course we have to reset it to retrigger it. Why don't we copy that? Okay. Now, of course, if we want to set some of these, like if we want to have sort of backward sounding attack, we can do ATK. Maybe make that quite a bit longer. And then we'll make this release very short. And 0.01, kind of reverse it, and then we'll make the sustain as well. Nothing, we'll just no sustain at all. Okay, so we hit that. And actually we can just do everything all at the same time. We can have our gate 1 here too. Okay, let's reset it maybe. Okay, oops. All right, so there you go. Okay, there you go. So that's, in a nutshell, in our modular synthesis or subtractive synthesis, we have added an envelope now to our waveforms. We've looked at mixing different sort of waveforms and ways in which you can use arguments to control the mixture, the amplitude mixture. And then we looked at envelopes, the different type of shapes of envelopes, and then also how to add arguments into our synth-def so we can control the arguments. And again, even though we keep expanding this already, this is quite powerful, and you can do quite a bit with this. You can have quite a rich synthesizer and quite a rich sound world just using this much. So that'll conclude part 2, but we'll see more in part 3.